Hi, so in today's video lesson, we want to look at what we call the relative motion. Relative motion, and what do we call by relative motion? Relative motion is actually the change in position of a body with respect to another body. So that means how object change position with respect to another. That's what we call relative motion. Relative motion with respect to another. All right. So we're going to be looking at three cases of relative motion. I'm going to be using just ship moving across a river, okay, or an ocean. Let's say case one. Let's say the first case. So we see we have this ocean of water. Then we have the ship. Okay, so the ship is actually moving. The ship is moving with a speed of 70 kilometers per hour. And the river or the ocean is flowing in this direction. And the speed is actually in this direction as well, with let's say 2 kilometers per hour. So now the question is, what is the speed of the ship relative with the ocean? So because they're in the same direction, the speed of the ship is actually going to be 70 plus 2. That's 72 kilometers per hour. Why? Because as this ocean is also moving in the same direction, you're going to be adding 2 kilometers to the speed of this boat. So the ship is going to be moving. If I'm staying at the shore, the ship is going to be moving at 72 kilometers per hour, while those inside the ship will be thinking they are moving about 70 kilometers per hour. But me at the shore, I'm going to be seeing they are moving at 72 kilometers per hour. All right, let's look at another case. Let's look at another case. Let's say case 2. Let's say case 2. And in this case, then you have the ship. Okay, now the ship is moving with the same speed, the same direction, 70 kilometers per hour. But this time around, the ocean is moving opposite direction to the ship, and that is in 5 kilometers per hour. So what's going to be the speed of the ship? Now, since the ocean is moving backwards, the ship is moving forward, then that's going to be the speed of the ship actually has to be 70 minus 5. And that's going to be 65. That's going to be 65 kilometers per hour. Yeah, so that means for me, the ship is going to be moving slower. Why? Because it is moving opposite direction with the flowing ocean, the ocean. Okay, let's look at the third case, which is going to be the last case we're going to look at. And so we have the ocean, then we have the ship. Okay, now we have the river moving in this direction with a speed of 3 kilometers per hour. We have the ship moving in this direction with the same speed, 70 kilometers per hour. Now the question is, what's going to be the relative speed of the of the boat. Okay, so let me draw that again. So that means it's going like this and then like this. Okay, so that means the boat is not going to be moving straight. The boat is going to be moving at an angle, probably like this, because this is the river is flowing in this direction. So it's going to be changing. It's going to be changing this position of. It's going to be changing this position. So that means as it's moving, it's pushing it. So it's changing direction. All right, so that means the resultant is going to be like this. So this is 3 and this is 70. So what is the speed along this side? So using your knowledge of Pythagorean theorem, you should have been familiar with that, and that is going to be, we don't know, let's call this relative speed. So we're going to have this as r squared equals 70 squared plus 3 squared according to Pythagorean theorem, because rs is actually the hypotenuse. So you have rs equals 70 squared is actually 4,900 plus 9, and that gives us 4,909. So we're going to take the square root of that, because this is square root of 4,909, and that's going to give us about 70.06 kilometers per hour. So then we see that the speed of the boat is increased by 0.06 kilometers per hour. So this is what we call relative motion, and this is how to calculate for different cases for relative motion. All right, good.